When talking about gravitational lensing, the first question to answer is a simple one. What is a gravitational lens? So take a situation where an observer wishes to view a source of light some distance away. Now say, between the two lies a distribution of mass capable of bending the light as it travels from the source to the observer. We call this a gravitational lens, and the effect of light being bent is called gravitational lensing. So essentially how this works is light is bent around the mass of the object as it travels to, in this case, your eye. Unlike a regular optical lens, light is bent most at the point which passes closest to the center of the lens, and is bent least at the point furthest from the center of the lens. When the source, the gravitational lens, and the observer all lie in a straight line, the light source will appear as a ring around the massive object. However, this is quite uncommon, and usually what is observed, especially in cases where the gravitational lens in question is not of a spherical but rather complex shape, are partial arc segments that appear as numerous distorted images of the same object. Let's take a look at the physics surrounding the topic. If one applied Newton's law of gravitation, which states that the force between 2-point masses is directly proportional to the product of their masses and inversely proportional to the square of the distance between them, we would be able to set up a diagram that would allow us to calculate the angle of lensing. The angle at which the source is distorted turns out to be 2 times the mass of the gravitational lens multiplied by the gravitational constant divided by the distance between the lens and the source multiplied by the speed of light squared. However, as was experimentally discovered and predicted by Einstein's theory of general relativity, this result turned out to be wrong by a factor of 2. The issue lied in the fact that Newton's classical outlook on gravity was seemingly incomplete. General relativity states that what we feel to be gravity is in fact a distortion in the fabric of spacetime, which is an amalgamation of both space and time. Distortion in spacetime is caused by something called the stress-energy-momentum tensor, which essentially comprises of mass, energy, momentum, pressure, and tension. These all combine to distort spacetime to produce gravity, much like putting a stone on a piece of paper would cause the paper to sink. In general relativity, light follows the curvature of spacetime. Hence, when light passes around a massive object, it is bent. Light follows warped geodesic lines across spacetime. In essence, these can be described as the equivalent of straight lines in flat space. So as predicted by Einstein's general theory of relativity, the angle of lensing turns out to be twice as was predicted by classical mechanics. An exciting thing to note is how in galaxies, the mass of the galaxy as a sum of the mass of all the visible stars in it turns out to be much less than the mass as predicted by gravitational lensing, which in turn provides evidence for dark matter, a hypothetical form of matter distinct from any other type of matter we are aware of, and this is one of the many exciting consequences of gravitational lensing.
Created using Powtoon.